So we are reviewing for the DPM. The DPM is Wednesday. So our DPM, well, sorry, it's now called a TEKS test. I'm using the wrong word, but it used to be called a DPM, so I'm sorry. I'm going to keep saying that this year. I'll switch to TEKS test next year. Anyways, it's going to cover everything we learned this semester. You should have a brochure. Sorry. If you're watching the recorded lesson, your teacher should have given you this brochure. 8th graders, you should have this, yep. And this just kind of goes over the topics we've learned this semester, okay? It starts with similarity and it ends with circles. All of these concepts will be on the DPM on Wednesday. There's 20 questions. So, what happens when you get even just one question wrong? You go down half a letter grade. So we want to get 0 questions wrong because we want to get a 100. Okay, so we need to know all of these topics because each topic could be worth 5, 10, or 15 points. And we want to all make A's or higher on this. Okay, let's go over the warm-up. Always, sometimes, or never. Similar shapes have congruent sides. Yes, Abby, yes. Similar shapes have congruent sides. Similar shapes have congruent sides. So we have to remember what similar means. 2 shapes are similar. We'll talk about this more in a minute. But they're similar if they have the same shape and different sides. Different size is what I meant. So, like these 2 shapes are similar, possibly, if their angles match. But also, these 2 shapes are similar as well because you're allowed to have more than the qualifications. You're just not allowed to have less. So congruent figures are always similar. Similar figures are sometimes congruent. So that's why the answer to number 1 is sometimes. Number 2, the diagonals of a trapezoid are congruent. The diagonals of a trapezoid are congruent. So I could draw a trapezoid multiple ways. I could draw that trapezoid, but I could also draw that trapezoid. So good. If the trapezoid is blank, then they would be congruent. What's the blank? Isosceles. If the trapezoid is isosceles, they would be congruent. If the trapezoid is not isosceles, the diagonals are not going to be congruent. Okay? Number 3, the diagonals of a rhombus are perpendicular. Good. That is a trait of a rhombus. That is a property. So when something is a property of a shape, then the answer is always. Like, I am a girl. That is a property of me. That's never going to change. I am female. And so if it's a property of a shape, a characteristic of a shape, it would be always. Number 4, the center of a circle is the midpoint of the diameter. Good. Always. That one's easy. A prism. Ooh, a prism has 7 faces. Can it have 7 faces? Oh, I see lots of sometimes. Which prism would have 7 faces? Oh, Abby was first. A pentagonal prism would have 7 faces because it's going to have the top and the bottom. That's 2. And then how many lateral faces is it going to have? 5, because it's a pentagon. So 5 plus 2 is 7. So we are loving the word sometimes on this warm-up. Sometimes for a pentagonal prism. Number 6, the diagonals of a rectangle form 4 congruent triangles. You mean they don't? So if I have a rectangle, remember when you're in trouble, draw a picture. When in doubt, draw a picture. Okay, triangle A is congruent to triangle A, and triangle B is congruent to triangle B, but triangle A is not congruent to triangle B. Could triangle A be congruent to triangle B? You've already said it, yes, if it's a square. Very good. So this one's sometimes, and It would if it's a square, but it wouldn't if it's just a plain old rectangle and it's not a square, then it would not form 4 congruent triangles. It would not. Okay? So we are going to, let me just talk about what we're going to review today real quick. Your DPM review today covers similarity. It's been the longest since we've done this. This has been a long time. And then it covers right triangles. And you guys are pros at that. So I tried to, on each DPM review day, I tried to put something that you need to remember and then something you're already good at. And then the next one has something you need to remember and then something you're already good at. That way I'm balancing them out, okay? Similarity we need to be reminded of. So let's go over it. Similarity. Let's talk about 3 of the main points of similarity. 2 triangles are similar if ... So there were 2 things, 2 qualifications for figures to be similar. One of them had to do with the figure's angles, and one of them had to do with the figure's sides. What's true about the angles of 2 similar figures? Not proportional. Congruent. Very good. The angles have to be congruent. You do not ever use a scale factor on an angle. You never use a scale factor on an angle. And then you got the sides right. The sides need to be proportional. So a proportion looks like that. And you've worked with those a ton. Okay? So that's the qualification to be similar. Whoa. How do you find the scale factor? How do you find the scale factor? What did I teach you? What did I brainwash you with? Second over first. Very good. If you remembered nothing else from the whole unit, if you remembered nothing else, second over first would be my favorite thing for you to remember. No, Johan, bad. Second over first. So you put a value from the second figure over a value from the first figure. Do you have to reduce? Of course you have to reduce. So if your scale factor is 4/6, like I grabbed 4 from my second figure and 6 from my first figure, then my scale factor is really 2/3. You always reduce. Do units matter? Do units matter? So let's say, let me go on a sidebar. Let's say you had 2 things that you're comparing. I just do triangles because they're easier to... And let's say you did second over first. This is the first shape and this is the second shape. Do units matter? Can I just put 2/6 and call it a day and go home? Units matter. Yeah, not drawn to scale, sorry. Units matter when you're doing scale factor. Now, when you're cross-multiplying, units don't matter because they're going to cancel out. Almost always in our class, they have canceled out. So, in a scale factor, it does matter. In a proportion, it doesn't matter. So, what would be the scale factor if it's 2 feet over 6 inches? What would the scale factor be? Well, you either convert them both to feet or you convert them both to inches. I don't care. Let's convert them both to inches. There are 12 inches in a foot, so this will be 24 inches over 6 inches. The inches will cancel, and scale factors, they don't have units. Scale factors should be unitless, so they should always cancel. Very good. So that means that this triangle would be 4 times bigger than the other one had I drawn it to scale. Good. Very good. All right. So do units matter? That was a yes. What does the scale factor look like for an enlargement versus a reduction? So what does it look like for an enlargement? What does it look like for a reduction? Okay, if your shape is getting bigger, what should your scale factor look like? Good. Your scale factor needs to be greater than 1. What should it look like if it's a reduction? I'm going to go a little bit more than that. For a reduction, we need to be less than 1, but watch out. We need to be greater than 0 because we don't really deal with negative scale factors in this class. So V is saying a fraction, but it has to be a fraction less than 1. It can't just be a fraction, because 6/3 is a fraction, and that's not a reduction. What if the scale factor equals 1? It's called a congruence transformation. Very good. It's congruent. Very good. Okay, guys, we are doing awesome. Ooh, what is a midsegment? This was the last thing we learned in similarity, well, that we're going to review over at least. And how does it relate to the base? What is a midsegment, and how does it relate to the base? So for this to be a mid-segment, this would have to be a midpoint, and this would have to be a midpoint. This, AB, is now a mid-segment. And how is it related to the base? Good job. In my picture, it doesn't look like it. I didn't put that in the middle. But it is half of the base. So if the base is 18 units long, then AB is 9. So the length of the midsegment is half the length of the base. All right. So we have now covered, look at all those slides. We have now covered similarity. Your review of similarity is over. Let's try some problems. Go. All right. So we want to go from ABC to A prime, B prime, C prime. So this is the first shape, and this is the second shape. The one with the prime is always the second one. The original doesn't have any primes on it. So if we look at number 1, did that, it's not even a trapezoid, did that quadrilateral get larger or smaller? It got smaller. So you know if your answer's 3, and you better believe that's going to be an answer choice. If your answer's 3, then you did not do a reduction. You are wrong. So, there's multiple ways to do this. One way to do it is to count the sides. This is 6 and this is 2. We put second over first, and that reduces to 1/3. The scale factor is 1/3. Answering 3 would definitely be wrong. That shape got smaller, not larger. Now, if you were answering number 2, then that's okay. The answer to number 2 is almost the same. This is 6 and this is 2. So when we do second over first, then we get 3. This one is an enlargement. So the first one's a reduction. The second one's an enlargement. Second over first. Okay, try 2 more. You don't actually have to transform it. It's asking for what the scale factor is when you transform it. I'll give you a second. I know it's hard to see, but at least you have numbers on there for you. Okay, so like I said, this one might be hard for you to see. You can use a coordinate, you can use a point and do second over first, or you can use a side length and do second over first. It doesn't matter as long as you're picking corresponding parts. When my side lengths are horizontal or vertical, I usually go with side lengths, but it really does not matter. The side length here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then, pretty sure Miss Tanton counted correctly. I hope so. Okay, we want to go from here to here. So we want to put second over first. Second over first. So final answer for number 3. 3/4. Very good. So this shape is 3/4 the size of JKLM. 3/4. Now, on the next one, none of those sides, we can't count any of those sides, of those kites or whatever shape they may be, quadrilaterals. We cannot count them, so we're going to need to use the coordinates. I would use this and this if I were you. This is the first shape, this is the second shape. So we're going to put second over first, and the scale factor is 7/2. 7/2 is greater than 1, and this is an enlargement, so we're good to go. You could put it as a decimal if you wanted to. You never know how they're going to put it, so you could put 3.5. Last scale factor one. Are we beating this one to the bush enough? Last scale factor. So last one, we want to put second over first is the last scale factor one at least. And so this would be 9, and the coordinate of this one is 3. So 9 over 3. The scale factor is 3. So that star is triple the size of star ABCDE. Triple. All right. Determine if the triangles are similar. We're still reviewing over similarity because that's the one it's been the longest since we've seen. So how do you determine if two triangles are similar, especially if we've rotated the triangle on you and you don't know which sides go together? Well, you pick the smallest number and you put it over the smallest number. You pick the medium number and you put it over the medium number. And then the large over the large. And you notice as you do that, 14 is to 6 as 21 is to 9 as 29 is to 12. Now, you can cross multiply these, you can divide these, you can reduce these. There are so many ways to do this. But if I divide each of them, I get 2.3 repeating. For the next one, I get 2.3 repeating. For the next one I get, oh no, 2.4. So they're almost similar, but almost doesn't count for anything. So the answer is no, the triangles are not similar. And this is the one that broke the pattern. So can you check just 2 of the proportions? 2 of the ratios? No, you cannot check just 2. You have to check all 3. Okay, I'm going to give you some time to do this one. Solve for x and y. I'm going to give you time. So this one you have to be really careful on because I really rotated and flipped those triangles on you. So you need to make sure you're using what's called the similarity statement when you're setting up your proportion. I'm going to try to find 2 numbers that go together because those 2 numbers are going to serve as the basis, the ratio, to find my other missing sides. Should we be having large fractions? No, I don't think so. All right, let's grab this number right here. BC is listed second, third. What else is listed second, third? GF. Okay, so 75 goes with X. Okay, let's try this one. AC is listed first and third. What else is listed first and third? HF. And then, of course, GH is going to go with AB. So I always do the circle, box, and underline trick. That way I know which ones go together. Okay, Johan, you don't necessarily need a scale factor, although you could use a scale factor. You can just set up a proportion. So I would say 34 is to 85 as, and then I'll do 42 is to Y. And then you can use that one again. 34 is to 85 as X is to 75. Make sure if you're going to travel this way that you travel that way every time. I just do second over first every time so that I can be consistent. Second over first, second over first, second over first. Good, Lars. Those are the correct answers. You cross multiply and you get X is 30 and Y is 105. Obviously, solving was not the tough part of this problem. It was setting up the correct proportions. You had to match the correct ones, and then you had to write them in the correct order. This is our last problem of the day. Solve for X and Y, please. Last problem. You don't know where they are? What are you talking about? So these parallel symbols, that means parallel. So these lines are parallel. And so when parallel lines are cut by a transversal, alternate interior angles are congruent. That's going to be the key to which sides go together. You can also mark your vertical angles as well. And I marked the alternate interior angles. So now I know that 8 is across from one arc. What else is across from one arc? Y is, so 8 goes with Y. That leaves X to go with 12, and then 15 goes with 10. So if I'm going to keep doing my second over first, then I would do 15 is to 10 as, we can choose any of the ones we want. Y is to 8. And then we can use this again. 15 is to 10 as 12 is to x. Just make sure you're going second over first every time. So what do we get? Y is 12, good, and x is 8. Yep, y is 12 and x is 8. Good job, guys.